Welcome to a journey beyond our solar system, where strange worlds orbit alien suns and the possibilities of life stretch far beyond our imagination. In this exploration, we'll dive into the most extraordinary exoplanets discovered so far and consider what they might reveal about the universe and about us. Water worlds. Perhaps colossal plankton-like organisms that shimmer under alien suns, or vast schools of bioluminescent creatures navigating lightless depths. The oceans could even give rise to intelligent life that never sees land, civilizations of beings shaped by pressure, darkness, and the currents of a global sea. And yet, water worlds may not be entirely welcoming. With no land, storms could circle endlessly without barriers, growing into hurricanes far stronger than any on Earth. Tidal forces from nearby stars or moons might create extreme waves and currents. Still, the resilience of life on Earth, surviving in volcanic vents, ice sheets, and toxic lakes, suggests that life might adapt here too. It's hard not to imagine what kind of sky one might see while drifting on an alien sea. Two suns, perhaps, or auroras stretching across half the horizon. In every detail, water worlds remind us that where there is water, there may also be life. But not all worlds are blue havens. Some are forged in extremes, where fire and wealth collide in forms we can barely comprehend. In sharp contrast to water worlds, some exoplanets are hellscapes of unimaginable intensity. Take Kepler-10b, a lava planet that orbits so close to its star, its surface is likely molten rock. Here, seas of lava replace oceans, glowing rivers of molten stone cut across the land, and temperatures soar high enough to vaporize metal. A world like this is a reminder of just how hostile the universe can be. Then there are the diamond planets, like 55 Cancri E. Scientists believe it could be made largely of carbon under immense pressure, transforming its crust into diamonds. Imagine standing on a world where mountains glitter like crystal and valleys sparkle under an alien sun. To us, it might look like a jewel beyond price, but to the universe it is simply another outcome of chemistry and gravity. These fire and diamond worlds challenge our imagination. While they seem inhospitable to life as we know it, they show us the extremes of planetary diversity. Some researchers even speculate that volcanic activity on such planets could fuel complex chemistry, laying a foundation for life in ways unfamiliar to us. After all, Earth's own volcanoes helped shape the early atmosphere and oceans. And beyond their beauty or danger, these planets may hold valuable lessons. Understanding their geology could teach us more about how planets form, evolve, and die. They reveal that the universe doesn't just create comfortable Earths. It creates jewels and infernos in equal measure. But what happens when a planet loses its sun entirely? What happens when a world is cast adrift into the cold, endless void? That takes us to the mystery of rogue planets. Rogue planets are cosmic wanderers. Unlike Earth, which orbits a steady star, these worlds float freely through space, unanchored to any solar system. Scientists estimate that there may be more rogue planets than stars in our galaxy, drifting silently between the stars. Imagine entire worlds lost in the darkness, warmed only by the heat of their cores. Though they sound desolate, rogue planets may not be barren. Beneath thick crusts of ice, geothermal activity could sustain subsurface oceans, much like Europa or Enceladus in our own solar system. These hidden seas could cradle microbial life, protected from the frozen wastelands above. The surface, however, would be an alien nightmare. With no sun, the sky would be a black canvas scattered with faint starlight. Any atmosphere would likely freeze, collapsing into snow and ice. Yet below, shielded from the void, life might quietly endure. It's a haunting thought. Entire biospheres hidden beneath kilometers of frozen rock, surviving unseen in interstellar darkness, rogue planets challenge our sense of belonging. They remind us that not every world needs a star. If life could thrive in such isolated conditions, it suggests the cosmos may be filled with living oases, hidden in places we might never think to look. But not every world is a frozen drifter. Some are giants of stone and ocean, larger than Earth yet smaller than Jupiter. These are the super-Earths, and they may be the true homes of alien life. Super-Earths are planets between the size of Earth and Neptune, and they are among the most common types of exoplanets discovered. While Earth is unique to us, the galaxy seems to favor these larger, heavier worlds. With stronger gravity and thicker atmospheres, they may offer stable environments where life could thrive on scales beyond our imagination. One famous example is Kepler 452b, sometimes called Earth's cousin. It orbits within its star's habitable zone, where temperatures could allow liquid water. If it has oceans, forests, or continents, they may be far grander than Earth's. Imagine mountain ranges stretching twice as high, seas deeper than our own, and climates more stable thanks to thicker skies. Super-Earths also raise questions about evolution. On a planet with stronger gravity, life might grow stockier, shorter, and more robust. Or perhaps creatures could develop differently in dense atmospheres, gliding or swimming through thicker air. Intelligent beings on such worlds may look nothing like us, but may share our curiosity and drive to explore. Astronomers are particularly fascinated by super-Earths because they seem to strike a balance. Too small, and a planet may lose its atmosphere. Too large, and it becomes a gas giant. But super-Earths sit in the sweet spot, large enough to be stable, yet small enough to remain rocky and habitable. And yet, not all habitable possibilities are found on planets themselves. Some may orbit the giants, just as Europa and Titan orbit Jupiter and Saturn. That takes us into the realm of alien moons. Moons of giants. When we imagine habitable worlds, we usually picture planets, but the moons of giant planets may be just as promising. In our solar system, moons like Europa, Titan, and Enceladus already hint at oceans beneath their icy shells, warmed by tidal heating from their massive hosts. Now imagine such moons orbiting gas giants in distant star systems. Picture a moon with oceans beneath ice, warmed by constant flexing from gravitational forces. Or a Titan-like moon with rivers and lakes of methane, where life might evolve along entirely different chemical pathways. These moons could even orbit within a giant's habitable zone, creating conditions ripe for life. Moons also offer spectacular skies. Standing on the surface, one might look up and see a planet filling half the sky, with swirling storms and glowing auroras dancing in its atmosphere. Nights would be illuminated not just by stars, but by reflected light from the parent planet. It would be an alien beauty unlike anything on Earth. And while moons may be small, their potential is vast. Life could exist in hidden oceans, or even on the surface of temperate moons. Scientists believe that habitable moons may be more common than habitable planets, multiplying the possibilities for life in the cosmos. But not all alien wonders lie in surfaces and oceans. Some of the greatest mysteries may be written in the skies themselves, in atmospheres so exotic they defy imagination. Alien skies can be more dramatic than any landscape. On some planets, winds whip at thousands of kilometers per hour, tearing clouds of metal and glass across the heavens. On HD 189733b, for example, scientists believe it rains molten glass, sideways, driven by winds 7 times faster than a hurricane. Imagine standing beneath a storm of glittering shards, a lethal but dazzling rain. Other planets may have skies thick with hydrocarbons, glowing with strange colors under alien suns. There are worlds where the air could be green, purple, or crimson, tinted by chemicals unknown to Earth. Some atmospheres might sparkle with metallic clouds, reflecting light like mirrors in the sky. To us, they may look alien and surreal, but to life there, it would simply be home. Exotic atmospheres also hold secrets. By studying how starlight filters through them, astronomers can search for signs of life, gases like oxygen, methane, or combinations that suggest biology. Each alien sky is not just a spectacle, but a clue in our search for neighbors in the cosmos. These strange atmospheres remind us that life could emerge under conditions we would never expect. It need not look like Earth at all. By opening our minds to these possibilities, we expand the definition of where life can thrive. And that brings us to the heart of it all, the search for life itself. Beyond landscapes, oceans, and skies, what we truly long to know is whether we are alone. The search for life is the driving force behind much of modern astronomy. Every telescope we launch, every exoplanet we study, carries the hope of finding signs of biology beyond Earth. The James Webb Space Telescope, for example, is already analyzing exoplanet atmospheres, hunting for chemical fingerprints that could reveal living processes. But life may not announce itself with grand signals. It may begin as whispers, subtle patterns in gas, or faint fluctuations in light. Microbes, algae, or primitive organisms might be the first discoveries, and even they would be revolutionary. Finding life elsewhere would prove that biology is not a miracle of Earth, but a natural outcome of the universe itself. And yet, there remains the possibility of intelligence. Civilizations may be rare, fragile, or long gone. But if one is discovered, it would forever change our place in the cosmos. The night sky would no longer be a silent ocean, but a vast community of voices. The search is as much about us as it is about them. By looking outward, we understand ourselves more deeply. We see how precious and improbable Earth is, and why protecting it matters. Every exoplanet discovered is a mirror, showing us both what is possible and what we must cherish here at home. And so, our journey comes to an end, but the exploration has only just begun. As we journey through the cosmos in our imagination, we're reminded of how small Earth is and how vast the possibilities are beyond it. From oceans without end to skies that rain glass, the universe is a gallery of wonders, and we've only seen the first brushstrokes. Every exoplanet we discover brings us closer to answering humanity's oldest question. Are we alone, or part of a greater story written across the stars? The truth may not come tomorrow, or even in our lifetimes, but the search itself connects us all, explorers on a pale blue dot, daring to dream beyond our horizons. If you enjoyed this journey, join us again as we uncover more of the universe's secrets. Until then, keep looking up, because the next great discovery might be waiting in the night sky above you.